for this video is to measure line segments and angles in geometric figures, including interpreting maps and scale drawings and the use of bearings. So we've talked about kind of, scale diagrams before in a previous video, so I won't be kind of covering that again, and same thing with maps. And measuring line segments and angles in geometric figures. So this is when, in the question, these figures are drawn accurately, and you have to get your, either your protractor out to measure angles or a ruler to get measure lengths. And since it'd be a bit impractical to show how to use these on kind of this whiteboard, etc. So I thought I've linked some stuff in the description below, but I think I imagine most of you are comfortable with using protractors and rulers, but if not, do check out that stuff in the description. What we will be talking about is the use of bearings, and what bearings are actually. So bearings are a way of kind of showing direction from north, basically. So what we have is, say we have a point here, and let's say this is, I don't know, this is me, alright, this is me, and there's some treasure over here. I need to go find that treasure. And if you're trying to direct me to get there, you might say, okay, man, you have to walk, I don't know, you might say, oh, walk a bit to the right and then a bit up or something like that, which might be a bit imprecise. If you've kind of ever done outdoor navigation and stuff before, what we do is we tend to kind of you get a compass out and then measure from say, kind of go east, go west, go etc. And a bit more precisely, what we do is we measure angles from north. So if this is kind of true north here, for example, let's just suppose it is, and this is the bearing I need to go on along this line, you'd say from north basically you need to go on a bearing of whatever this angle here is. So maybe this is 45 degrees. So you'd say you have to go on a bearing of 45 degrees, and when you say that, I know I kind of go look at north, find out where north is, and from north go 45 degrees kind of clockwise. So that's what a bearing is. And a bit more kind of precisely, when you give a bearing, you need to give it in three figures. So if it's 45, you'd have to say 045 degrees. This first amount is actually quite important. A lot of time I've made so many silly mistakes and forgotten that zero and lost marks because of it. So even if kind of the treasure was, all the way over here, you'd still have to kind of give the bearing from north and say, look at this angle over here, which might be, I don't know, what's that? That's more than 230, isn't it? Maybe say, I don't know, that's 240 degrees. So you'd have to give this angle over here. So you look at where true north is, and then go clockwise to the, I guess, to the angle you need to walk along, basically, or go along. And make sure you give it to, three figures. And that's kind of all there is to bearings. Two things to remember: give it from north clockwise, and three kind of significant figures, or make sure there's three figures involved. We'll do some questions now, worked examples. Work out the bearing of B from A. Another thing to know is that it's always irked me so much, the fact that the question would say of B from A instead of saying A to B. But that's just how bearings work. So you'll be given kind of, I guess, the destination first and then where from afterwards. So you're being asked to work out the bearing of B from A. So how do you go from A to B? So this is north here, and what's the bearing you have to go on to find B? So go ahead, pause the video, just kind of try giving that an answer. So remember, bearings we have to get from true north. It's just the angle from true north. So we go clockwise. We go this thing over here. So go from here to here. So what angle is that? Well, we know this thing over here, this part here is just a straight line. So that's 180 degrees. So you go 180 degrees, and then you go an extra 40. So what is that? 220 degrees. So the bearing is just 220 degrees, and that's it. Bish bash bosh, job done. We have another one here. The bearing of a ship from a lighthouse is 050. Look how it's the three of these figures, whatever. Work out the bearing of the lighthouse from the ship. So this is kind of asking us to reverse it. The way I do this, you might be able to do this in your head or something. I'd be kind of too scared to be honest. First thing to do is draw a diagram out and then give the question a go. So I do really encourage you to actually pause the video, give this a go, and see what answer you get. I have a very strong feeling that you didn't actually pause the video. I mean, I'm just getting those feelings, so prove me wrong, go ahead, actually do the question. Okay, well, I hope you've done it, you know. I'll wait a little bit longer anyways. So unless you just want to look at me for a bit, you might want to go do the question. Cool, okay, you've probably done the question by now. So the way I do this is firstly draw a diagram, because it's hard to visualize this kind of stuff. So we have, you know, we're looking for the bearing of the ship from the lighthouse. So if information is given in this order, I'd go lighthouse, and then stick out true north. And the ship is, you know, 50 degrees from the true north here. So 50 degrees, well, this is 90. So 50 would be something, you know, along like this. Okay, so, you know, this is 50 degrees to me. We have our ship here. True north is going to be parallel to this, because, you know, think about it, north is going to be, in whatever distance this is, the north is going to be in the same direction, right? You might be saying, oh, you know, the Earth's curved, and if it's a long enough distance, then, you know, the norths might not be parallel to each other. Yeah, I guess you're right, but in questions like these, you assume the distance isn't large enough for kind of north to be affected, so just roll with north being parallel, or, you know, you'll struggle to do the question. And now what we're asked to do is find out this bearing over here, right, from the ship, of the lighthouse from the ship. That's what we're being asked to find out. So if you remember kind of our stuff about co-interior angles, so this is 50, and if that's 50, this is going to be 180 minus 50 over here. So what's 180 minus 50? 130. And this is 130, you know, this thing over here is going to be 360 minus that. So 360 minus 130, what is that? 230. So the bearing is 230. There we go. And, you know, this came from an exam question, past exam question, and at the bottom there's the answer kind of ... degrees. So here I'd write 230. Or else if it was just this kind of question, I'd write out in full, you know, the bearing of the lighthouse from the ship is 230, but since it comes from that kind of question, you know, there you go. Sometimes the bearing questions are a bit harder than this actually, because what they involve is sort of some form of construction, and then, you know, use of cosine rule or sine rule or whatever, something like that. So with those kind of questions, super important is, you know, just draw a half decent diagram at least to make your life easier. You know, if you can, get your protractor, get your ruler out, and that way also, you know, this is a bit cheeky, but in the sense that if you kind of draw a diagram that's accurate enough, you can almost read off the answer. I don't recommend you actually always do this. I'm just saying this as a sense that you can kind of check your answer in that way. So obviously, you know, you wouldn't really get the marks per se for just drawing out really nicely and then measuring off the answer. But if you draw decently well, those kind of in these tougher questions, if you do some practice, you'll see what I'm talking about. Just draw out the diagram really neatly, and when you get an answer, you can kind of compare it to the ruler and see, oh, you know, in the sense that if you can see you're around about the right kind of measurement, I guess. So again, in general, when it comes to bearings and these kind of questions, diagram is super important. I can't stress enough. But yeah, hopefully all that all made sense, and I'll see you guys in the next video.